Good morning. Here is a video presentation on the last sections that you completed in the CK12 workbook, which talked about constellations, how stars are classified, the power in stars, and how stars are created. So the first section was on constellations. Now, constellations by themselves, really what they look like, that was just what somebody looking up at the night sky saw in their mind's eye. They looked up at the night sky and they basically connected the dots to make pictures. The constellations are named mostly after animals. There's goats up there are swans, there are scorpions and crabs, but there are also heroes like this guy over here. This is Orion. He's a hero from Greek mythology, son of Poseidon. He's known as the hunter. And in the mythology, he was hunting Scorpius, the giant scorpion, which is the zodiac sign for Sagittarius. And I don't want to give you a spoiler alert, but Orion doesn't win that confrontation. He gets stung and he dies. But he's immortalized. He's up there in the stars. The constellation can be very distant, and these stars that make it up are not necessarily going to be very close to each other. They look close to us because of our perspective, but these stars can be millions of light years distance from each other. They were useful in plotting out the seasons and the year. And the reason for this is the stars that we're able to see in the summer, we can't see those same stars in the wintertime because as the Earth is moving around the sun, the portion of the night sky that we see changes. So it appears to us on Earth that they're moving across the sky from east to west over the course of several months. The zodiac signs, probably everybody knows what your zodiac sign is. Well, your zodiac is named after a constellation. So during the month of your birth, whatever it is, that constellation will be visible in the night sky. Constellations today help us locate important stars. For instance, you might have heard of the North Star, which is a star that if we were looking, it's right above the North Pole of the Earth. So if you're ever lost and you're trying to find your direction, if you could find the North Star, you could orient with that. And that's what astronomers use constellations for today. So those stars are all very far away from us, but they look close, but in reality, they're spread out over a huge region of space. Looking at those stars in a constellation, there are several that are closer to us here on Earth than they are to each other. They could be light years apart. If you're not familiar, a light year is the distance that a beam of light can travel in 1 year. What's easy to see for the constellation Orion are the 3 stars that make up its belt. So if ever you're looking up at the sky in the summertime and you see 3 stars that are all in a straight line, you have found Orion. He's one of the easier ones to find. Some other constellations that you're probably familiar with are Ursa Major and Ursa Minor. Those are the Big Dipper and the Little Dipper. Also, those are ones that you could find pretty easily once you start getting used to looking up at the night sky. There's actually a really fun app that you can get for your phone. It is called, I want to make sure I'm saying the right name. Where did I put it? It's an app that if you point it up at the sky, it will name all the stars that you're looking at. And it's a lot of fun. My kids have it on their phones, and I'll put the link to that later on on the Google Classroom. It's called Skyview Light, and it's a really nice app. And you could actually use it to look at stars in the southern hemisphere that you would never be able to see in our sky. So in summary, the points of light in the night sky are stars that are balls of superheated gas called plasma. They are lit by nuclear fusion. Constellations are patterns of stars seen from Earth. These stars are usually not near each other. And stars in a constellation may be fairly close together, but more likely they are extremely far apart. So where did stars get their power? They create enormous amounts of light and heat, and that's all because of a process called nuclear fusion. In nuclear fusion, atoms slam together with such force that the nuclei, the center of those atoms, actually fuse together to form a heavier element. In our sun, like most other stars, hydrogen is the lightest and simplest of all the atoms, and they collide to form a larger atom called helium. That's the second simplest of all the atoms. So hydrogen being converted to helium by fusion creates an enormous amount of heat and light. This could only happen at great temperatures and extreme pressure. The pressure is coming from the gravity that star is exerting, and it's forcing those atoms closer and closer together. They're colliding much faster, and eventually fusion starts. Compared to the other stars in our galaxy, our sun is a slightly below average star. You'll see that other stars that we're going to look at are much bigger, they burn brighter and generate more heat, while others are smaller and cooler. One of the ways that we could try to understand what's going on inside of a star is by using a particle accelerator. And this is a very complex piece of machinery that takes individual particles, which are bits of atoms, things like protons and neutrons, and they fire them at each other at near light speed and collide them. And when they crash together, they form different particles. Some of those other particles are called hadrons and bosons and muons. And by studying the properties of these particles, scientists are hoping to figure out what it was like at the very beginning of our universe. And some of them are hoping to find a way to capture the energy that's created through nuclear fusion. If we're able to do this, it's going to give us an unlimited source of energy. We'd never have to drill for oil. We'd never have to build another windmill or solar panel. We'd have enough energy for everybody, basically forever. We haven't figured it out yet, but that is one of the goals, and people are working hard at it every single day. So, star power summary. In a nuclear fusion reaction, nuclei combine to form a larger nucleus. The energy from fusion reaction keeps the star shining, and particle accelerators simulate nuclear fusion in stars. So, all stars are not the same. The type of star they become all depends on how much matter they have when they are born. How much is present when nuclear fusion begins. If there's a lot of matter present, the star is going to be larger, it's going to be hotter, and it's going to be brighter. The stars that are the hottest in the night sky are white or blue in color. Stars on an intermediate temperature are yellow, like our sun. And the coolest stars are red, though some of them are so big they're called red giants or even red supergiants. And this is what we believe our sun is going to become someday. It's going to become a red giant, but fortunately not for a while. The way we classify stars is on this diagram called the Hertzsprung-Russell diagram. Most of the time you'll see it shorthand, just the HR diagram. And what we're looking at here is each of these dots represents a different star. On the y-axis we have luminosity, which is how bright the star is. And down here on the x-axis we have temperature in degrees Kelvin. Kelvin is the unit of temperature that astronomers use. It goes from 0 to however hot it can get. So 0 is what we call absolute zero. At that point there's absolutely no kinetic energy. Theoretically, at that point, electrons would stop orbiting the nucleus of atoms and probably collide inwards. We don't know. But as you can see, the coolest star is a red star. It's about 3,000 degrees Kelvin. And as the stars get hotter, you could see that they're also getting brighter and changing color. So we're going from red to orange to yellow, through a range of greenish stars into the blue. And the blue stars are the brightest and the hottest. Over here we have the most massive stars. These are called supergiants. Other very large stars are called giants. And down here we have a class of stars that are small but very, very hot called white dwarfs. And we'll learn all about these different types of stars in a later lesson. You're going to be doing some CK work on them. I'll make another presentation like this about them. The life cycle of stars are measured in millions or billions of years, and what might seem counterintuitive, The more mass a star has, the more fuel it has when it forms, the shorter its lifetime, because those stars burn through that fuel so much faster because they are so much hotter and brighter. So the bigger the star is at its birth, the shorter its life cycle going to be. So in summary, in nuclear fusion, nuclei combine to form a larger nucleus. We already talked about that. Star formation. As I mentioned earlier, stars go through a life cycle where they will change size and color during their lifetimes. The pathway they take is determined by how big they are when they form, but where do they come from? Stars are born in vast regions of space called nebula. A nebula is a cloud of gas and dust. In the nebula, the atoms of gas begin to become attracted to each other by gravity. Now, an individual atom doesn't have much gravity, but it has some. And over a long period of time, this gravity acts on other atoms and it begins to attract them to each other. As they begin to congregate, they gain more mass. The more mass they have, the more gravity they have. And this increased gravity then generates more atoms to be stuck to it, and it gets larger. The gravity increases, so it gets larger, and so on and so forth, until they're forced together so closely and the collisions are so constant, and it gets so hot, nuclear fusion begins. And once that does, that star will burst into existence, and a new star will be born. Here are images taken from the Hubble Space Telescope. They call this the Pillars of Creation, and this is just a section of what's called the Eagle Nebula. And this is where new stars are being born. They call this a stellar nursery, a place where new stars are born. So in summary, stars are formed in a nebula. A nebula is a cloud of dust and gas. And nebula can be spotted with the naked eye. It takes a clear night with no clouds and no moon. And if you go out and you look up at the night sky, you'll see the stars all very clearly, but you'll see these hazy, glowing sections out there in space, very distant, that it's really hard to focus on, but you could see them. Those are nebula, and that's where new stars are coming from. All right, so this is just covering those last 4 sections about stars. I'll be putting out the videos like this more frequently as we go through more of the CK12. Have a great day.